What we're going to show you today is actually a bit of a recap. Some of you may have seen the Medium article, and I don't know if any of you came to Vancouver. We gave this talk at the IEEE Viz talk in Vancouver this year, and it was pretty fun, actually. And I'm going to reproduce a little bit of the lively conversation that we had at the end. Does AI mean data visualization is dead? This is a little bit of a clickbaity title, perhaps, but I've got you here. So we did a little introduction, just to sort of recap. We're part of the UX design team for Cognos Analytics, and the way that our organization is set up, we have there's offering managers, there's developers, and then there's designers. And then within the design side, you have visual design and you have UX design. And we're the UX team, although Fruit is actually also so we work in the downtown Toronto studio. I don't know if you've ever seen it. It's like Queen and Spadina. It's a lovely building. It's like a 100-year-old building. And it's a really happy place. So we don't have openings now, but we often do. And IBM has more designers on staff than any other company. I think we have 2,500 designers between all of our studios. It's the company has actually, I'd say, reinvented itself over the past 6 or 7 years to be a design-driven place. So as if you do see openings, I totally encourage you to apply because it's really great. Okay, just to let you know what we have planned for tonight, I'm going to just give you a bit of a recap of what Cognos Analytics is and sort of the space that we're coming from. Then we'll give you the Viz talk and the meat of the impact of AI as it relates to business intelligence and data analytics. And then we're going to open this up to discussion and not just sort of fake discussion, but we really do want to hear what you have to say. And in the spirit of that, we brought Post-it notes because I think IBM has stock in Post-it notes and charts. And so we have orange and green. And what we'd like you to do, just sort of as we're talking, is take note of things you don't agree with, or that you think, well, hold up, guys, let's just talk about that. And also things that resonate positively with you. So take notes as you go, and then when we get to the wrap-up, we'll actually, I'm not sure if we'll do the whole clustering exercise or anything like that, but I don't want to lose your comments. So let's just start with getting some definitions out of the way. I mean, I guess we all kind of know what AI is, and we all kind of know what visualization is. But just so that we're to sort of level set what we're talking about here. When we talk about AI, I mean, AI is pretty broad. Like, you could just sort of take a whole bunch of sort of if-then scripts and you sort of nest them and build some sort of intelligent action. What we're talking about when we refer to AI is the advanced analytics, these advanced algorithms that, from a human perspective, perform high-level analyses, that find patterns in data set, that find outliers, that ability to cluster and label and do all that stuff that previously people did. And then when we talk about visualization, like, I would love to just come here and talk to you guys about visualization, but we can do that in a separate evening. But really, the purpose of visualization, not just about encoding information so it can be decoded, is to help people solve problems. It's task oriented. When people have more data than they can sort of see a trend, like if you have a table of data and somebody says, hey, can you see what stands out here? really the best way to do that would be to chart it. And by visualizing the data, you can fulfill, you can answer your questions and move on. So what we're seeing a lot these days as AI is developing is it seems like we're able to ask computers to do things that previously we would have answered with a chart. If you feed a whole pile of data to the computer and say, well, what do I need to know here? Whereas typically you might have made a bar chart and sorted it, and the chart with the highest things, or it's just the answer pops out to you. Nowadays we can perhaps even bypass the chart. So what we wanted to know is, what does that mean for data visualization in general? If AI can actually sort of fulfill so many of these tasks that, yeah, perhaps we don't need data visualization anymore, and that's terrifying to us as visualization designers. Just gonna skip that. So when we talk about tasks, fulfilling tasks, I also want to sort of say who we're doing this for. Because we're building software for businesses, enterprise software, really our users are business users. And in the past, Cognos is like a 20-year-old program, and in the past, the business users that would use data visualization packages were trained to use these packages. In fact, it used to be that you would have Cognos Analytics in your job title. Like you get a job at RBC or TD and you'd be like a Cognos Analytics developer, or you're a Cognos analyst perhaps. And I mean, the industry is changing really quickly with Tableau, and Domo, and Looker, and ThoughtSpot, and Click, and like there's a lot of different products that now exist that sort of make it easier to get answers from your data. And what we're finding is we can't count on users to know how the software works. So we have to sort of basically design it to just be a lot more user friendly. So what is Cognos Analytics? It's IBM's flagship business analytics, business intelligence platform. It is used by airlines, it's used by oil companies, the CIA is a huge client. People use it for dashboarding, which, I mean, I think you guys probably, there's a funny distinction between dashboarding and reporting, but I'm just gonna sort of combine them all together. People use it for dashboarding and reporting, and on the fly sort of modeling and exploration. But over the past few years, we've been adding a lot of AI features to this product, such as forecasting, where you can take data, like time series data, and forecast it forwards. Basically, relationship analysis, so you can find out like how one field relates to another field, and what's the predictive strength between the fields. Driver analysis, decision tree analysis. This is a new one. Can we get the charts to actually tell you what's interesting in them? Can we actually sort of design a system that says, well, this is the average, and these fields here are actually quite different and noticeable, you should pay attention to that. Conversational interaction, where you can sort of say, open this data set, and it says, do you mean this one, that one, or the other one? How many average days of resolution to blah, 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 and it's like, oh, here's a chart. So that's Cognos. And sort of with that as the background, we started asking, what is the impact of AI as it relates to business intelligence tools? So I think Anna's going to step in here. Okay,
thanks a lot. Okay, so Thanks for introducing yourself. So I want to just take another kind of like a little bit of snapshot of the audience here. So just a show of hands here. How would you describe yourselves in terms of the role you do? Would you describe yourselves as designers? How many people? We got, yeah, half dozen. Engineers, developers, computer scientists, about 3. Data scientists, data engineers, 2. Okay, great, thank you. And second show of hands, how would you sort of rate your experience level with AI? Low? Oh, half dozen or 8 or so. Medium? 4 or 5. High? 1. People are probably being modest. Okay, great. Thanks, guys. So, why did we undertake this research about the impact of AI on data visualization? So, as you've heard already, we're passionate about data visualization, and we work in that field. So that's our day-to-day, our task, our role, our focus area. But more and more, we also find ourselves designing for AI experiences in our job. So it sort of became a kind of increasingly sort of important question for us about how do these two things intersect with each other and impact each other. And what are the implications for data viz, as Jamie sort of talked about, what are the implications of AI on data viz? If you can automate a lot of the day-to-day kind of low-level operational decision makings of a business, do we need as many dashboards as we've sort of come to rely on in the past, or at least as we know them? If an AI can identify relationships in the data and outliers and kind of package up the information, almost take a question and provide an answer and nicely package up the information, what does that mean for data viz in general? So, these are big questions for us, and since we're surrounded at IBM by a lot of smart people working at the intersection of AI and data visualization and working on data viz products and working in different capacities, research, etc., we thought we'd do a little research, try ourselves. So now, so as I said, we're sort of tapping into the collective wisdom at IBM. It's kind of a big place. So we wanted to reach out and find out what we could find out. Now, we did this research, a lot of it happened in August, September last year, and we sort of packaged it up and presented it in October at the IEEE Biz conference. So we sort of think of this as a snapshot in time. What was IBM thinking in 2019? And then maybe, a year or two from now or something, we'll repeat the exercise, because it's a rapidly evolving field. So it might be worth repeating the exercise and see what we find out and how it compares. And it was interesting. We wanted to understand where people and their ideas converged, because that's interesting, but also where they diverged, because that's interesting too in a different way, because that points to things that we maybe have to pay more attention to, because we're not completely sure what direction they're going to go. And then as design practitioners, we also wanted to sort of take away some key learnings about what's most actionable and what we might be able to kind of build into the experiences we design in Cognos Analytics. So that was sort of our motivation. We're hoping that you find something interesting, maybe here, or answer a question of your own, or maybe seed a question you hadn't thought of already. So this is what we did. We interviewed 15 practitioners at IBM, all with a range of roles, a range of backgrounds, education levels, and geographies. We kept our interviews inside IBM. There was sometimes we were referred to people outside of IBM, but you have to sort of stop somewhere. You can't just keep going. So that's the rules that kind of we set for ourselves. And we opened every interview with this icebreaker question. And it comes from an article, a Medium article by Nicholas Crookton, and he's with He works in product for Plotly, and he wrote this article called Data Visualization for Artificial Intelligence and Vice Versa. And he posed this question suggesting that the more AI succeeds, the more data viz might become irrelevant. At least that's how he opened. But he sort of also asked this rhetorical question: do you need a speedometer to visualize how fast the car is going in a self-driving car, if it's driving itself? So that was kind of the, like I said, the icebreaker that we started every interview with, and then we kind of went from there. So I want you all to keep that question in mind, because we're going to come back to it at the end of talk, and we're going to ask your thoughts and positions on that. So, do you need a speedometer in a self-driving car? Answers range from not really to hell yes. And being data visualization designers, we put the answers into a chart or a diagram. So just to kind of quickly go over it, some of the people thought, no, I don't need an answer. I don't need a speedometer in a self-driving car. It's like having speedometer in an elevator. I don't need that. I know that I trust the elevator to work at this point in time. We've had elevators long enough. Or, same goes with the microwave. And then on the other side of the decision tree or the opinion tree, a lot of people thought, yeah, absolutely, I need a speedometer because I'm never going to trust the AI 100%. So this theme of trust and control came up a lot. And for example, what if the car encountered a situation it wasn't trained for, like a gravel road, a detour for emergency construction, something like that, a child and a grandmother in the road. I need to know when to take over, kind of thing. So we had these 15 interviews, a lot of interesting conversation and discussion, and certain themes kind of bubbled to the surface or kept emerging. And the main ones that we're going to address today are: how is AI transforming the field of data visualization? How AI is transforming the role of the user, the traditional data visualization user, the analyst, both the expert user and the non-expert user. And what are some of the challenges of implementing AI features into product? And this is a little bit more like, reports from the battlefield, like real life stories kind of thing. But that's the reality of kind of, you don't get immediately to the end of your journey. It's a journey getting there. So I'm going to start with the first one, and then we'll pass it around. So does AI transform data visualization? Guess what? Difference of opinion. Some people said no, not really, and some people said yes, absolutely. So on the no, not really side, there were a range of opinions, and some people reflected that when it comes to human perception and principles of pre-attentive perception, that's not going to change, at least not in our lifetime. Maybe long-term evolution it might change, but not in our lifetime. Perceptions and perception is perception. And chart primitives, by that I mean like the basic charts, the bar chart, the line chart, the pie chart. Those aren't going to go away anytime soon. Those are the workhorses, one of the participants said, the workhorses of business intelligence, and they're not going to go anywhere quickly. Some people express that there's no real dependency between AI and data visualization, because analytics happens under the hood, like in the engine. Whether it's just descriptive analytics, whether it's predictive analytics, whether it's a really complex machine learning model that's spitting out predictions or some kind of outputs. All that heavy lifting happens under the hood, and really the visualization is just pure output on the surface. So there's no dependency there, and we heard that from a few people. And also, some people express that visualization is not going to go away because we need it to help understand the AI and help build trust in the AI. Just like in that self-driving car, you still need a dashboard. Most people thought, yeah, I want a dashboard. Whether I want speedometer or not, I still need some inputs and outputs. You know, I know when am I going to get to my destination, things like that. And just like some of those things, maybe the speedometer and some other things, give you enough feedback about the performance of the car that you kind of trust it. And at least you come to build trust. And you also know when to take over if you have to. We still are going to need dashboards and visualizations to help us understand the model, have enough context around the AI-generated output to actually judge whether we should act on the output or not, and to build trust gradually in the AI. And then the other thing that came up was like, okay, we're talking about business intelligence. It's people making business decisions. So even though computers can automate a lot of low-level decision-making, the truth is business intelligence is complex, it's dynamic, changeable, and it can be a bit fuzzy. And you can't take the human out of that decision-making process, at least not at the moment. So dashboards and visualizations are still going to be there to support that high-level decision-making. Now, on the yes, absolutely side of the opinion tree, we had a few people express that, just simply pure automation, the more AIs automate basic day-to-day operational decision-making, take the human out of that operational loop, it stands to reason the less dashboards we're going to need, less dashboards cluttered with KPIs and dials and gauges and performance indicators. And that's just going to mean purely less volume of data visualization. And then we had some people express the idea that it's not like data visualization is going to go away or charts are going to go away. It's like what we visualize is going to change. Because in that self-driving car, I may not need a speedometer to tell me exactly what speed I'm going. But if I'm going slow for some reason, I want to know why I'm going so damn slow. Is there an accident up ahead? Is there a construction zone up ahead? Is there bad weather? Something like that. Is there something I can do about it? So the idea is that like speedometer gives you some pure data. That's fine. But in the era of AI, you actually more sort of high-level information is actually more useful, like the weather data or the accident traffic report or something like that. So that's the kind of information you're going to want, and that sort of AI lets you get out of the weeds of the data and up into sort of a level of information. And then a number of people also addressed the question about uncertainty and data quality. They felt like AI poses some new problems for data visualization that we have not yet tackled or solved. And that has to do with things like uncertainty, data quality, probability, that sort of thing. So in traditional data visualization, you have a set of historical data, you analyze it, you summarize it as required, and you project it into a chart. And it implies there's a kind of authority to that chart. You assume the chart is precise and accurate as the data is. But in predictive models and AI algorithms and machine learning models, they're always probabilistic. There's always a degree of uncertainty. And so if you are in a position where you have to make a decision based on output from a predictive model or a machine learning model, you need to know what the data quality was, what the degree of uncertainty was, what the predictive strength is, so you can act on it. Because you know what, it depends what situation you're in, whether how much uncertainty you can tolerate, right? Whether you're just deciding to take an umbrella with you to work that day, or whether it's a life and death decision, like in healthcare or something like that. So some people felt, actually, this is a different implication for data viz, that there's a lot of work that we still need to do to represent data from AIs. And in terms of AI processes, a lot of people talked about the fact that data visualization can help shed light into the black box of AI, or of machine learning models. Machine learning models can be incredibly complex, even to the people that build them, and difficult to understand and to tweak and that sort of thing. And so a lot of people are looking to data visualization to help represent that in a more understandable, less abstract way. And there was a lot of consensus around that. But we also heard a word of caution that, be careful, because if there's 300 dimensions of data in the AI model, and you try to represent 300 dimensions of data in a visualization, you're just gonna have like a mess, right? That human being cannot consume or understand. So there's some that you have to be able to aggregate or roll up or summarize or do something to make that actually consumable by a human being and actionable. Sorry, I got ahead of myself. That's there. And then a couple people talked about the fact that, okay, remember I said a few minutes ago, some people thought that data viz was just an output channel, agnostic of the analysis that went in under the hood. But there's other people that said, actually visualizations can be the inputs to models, because we already know that AIs are really good at image processing, finding patterns, finding outliers in images. And we could feed charts and visualizations and maps into an AI and have it do some processing on the images. And what that could be used for in all kinds of output, or even just for sort of augmenting the images with labeling and that sort of thing. So that was a nice sort of like inversion of what we heard from some other people about data viz just being a kind of neutral output. So my takeaway from this was that what are the impacts? Does AI impact data viz? Well, it's complicated. There was a lot of difference of opinion. It kind of reminded me of the parable of the 6 blind men and the elephant. Everyone sort of had their own limited experience of the elephant, and they all think the elephant's a different thing, depending on what part of the elephant they feel. And I guess maybe that goes for a lot of us working in the area, that we're not at the end of our journey in getting to AI. We're just partway along, and we have a certain amount of experience and knowledge about it, but I certainly don't have a full experience. So we heard a lot of different opinions. That was interesting, even within one organization. Not really surprising that there's a lot of difference of opinion, to be honest. And as I said before, sometimes the differences of opinion are at least as interesting as the points of convergence or the agreement. So, does AI impact data viz? It depends. Is AI going to make data viz go away? Pretty much the consensus was no, it's going to stay for one reason or another, but reasons varied. And now I'm going to hand it over.
Thank you, Anne. So, another topic that we discussed with our participants was how might AI transform the role of our users. So we divided the answers that we received based on how might AI transform the role of the end users of business intelligence tools, the domain experts, and data visualization experts. So how would AI change the role of the end users? Some participants believe that automation reduces the analyst's role. So as AI helps humans complete their tasks faster and more efficiently, and potentially more accurately in the absence of human biases, this would potentially reduce the analyst's role. So because analysts would be freed from doing a lot of the mundane tasks, now they can focus their energy on more higher level decision making. these group of participants believe that similar to how in a self-driving car, the role of the driver is changed to a passenger, in the case of business intelligence tools, and when AI is added to those tools, the analyst could become more passive. So once AI advances to the point where it can be trusted and it can successfully do what it's meant to do, then the AI agents will become the main players driving the data analysis process, and the humans could potentially become secondary. But many of the participants had an opposite point of view. They believe that although a lot of tasks will be accomplished faster and more efficiently, humans are still in control of driving the analysis process and decision making, because they would not only base their decisions on the AI recommendations, but they would use the AI recommendations as sort of assistant to make better and more informed decisions. We also heard from this group that AI could, in a way, expand the analyst's role, because now they would have access to new types of data, the data that they didn't have access to before. So for example, we can now do sentiment analysis to understand customer analysis, to understand customer sentiment. Previously, we just had access to basic sales data. And one of the points brought up by some of our participants was that we will see new skill sets in the future. For example, we'll see people with more blended skills. So in the future, the distinction between the roles might go away. And so people might differentiate by level of expertise, but less so by domain. In addition to that, these participants believe that data analysis and model creation will become an integrated part of many roles and domains as the new generation develop more computational skills. So programming languages like Python is like a second language to many Generation Z workers who started learning Python in their math classes at the age of 14. So they would be pretty comfortable developing predictive models to help them doing their jobs better without necessarily being advanced data scientists. So how about the domain experts? AI could transform the role of the analytics user for a number of reasons that center around domain expertise and evolving skill sets. So currently there's a knowledge gap between the people who build and develop the models and people who understand the data and the context that the data is being used. So this gap that is increasing, this gap could be closed using the domain experts of those fields. And these are the people who can bridge, sort of, because they understand the context of the data, they can help with training the model. So in a sense, their role wouldn't be eliminated, it would just be shifted. And then finally, data visualization experts. Thanks to the recent advances in visualization recommendation systems and conversational assistants, like the examples that we showed, it is entirely possible that there will be a reduced demand for dashboard designers. But this doesn't mean that there will be a reduced demand for data visualization expertise. Several participants emphasized that if mundane tasks can be handled automatically, data visualization experts will have more bandwidth to focus more on storytelling and to building more bespoke visualizations. This is something that the AI systems are not yet capable of doing. So data visualization expertise will become more important, not less, especially when it comes to visualizing complex models that are using hundreds of features. So will business analysts still be in a driver's seat? Again, it's complicated. Some of our participants said that if the system is trustworthy enough, there's no need to know what's going on under the hood. But others felt that the next generation would be AI savvy enough to expect a degree of visibility into the model for the sake of trust and oversight. This juncture, people's comfort level with AI is changing rapidly, and we should avoid jumping into easy conclusion on the question of transparency. Now I'm going to hand it to Jamie to talk about some challenges of implementing AI.
So, what are the challenges of implementing AI features? And just to recap, like, this is really, we're sort of at a it felt like us, like we were at a crossroads for data visualization. You know, whereas it used to be just great that you can load up a data set and drag fields in and make bar charts. And what we're finding is that every tool in the industry that does just that is not enough. The Gartner reports and everybody who's evaluating software that does what ours does basically says the AI features are the differentiating features. The future is all about AI. So we're looking at the problem. It's like, okay, well, so how do we react? How do we adapt our tool to accommodate this? So we talked about the how AI changes data visualization. We talked about how AI changes the role of the user of data visualization. Now let's talk about, well, how realistic is this? What are the challenges of actually implementing AI features into BI tools? And back to our charts, what we found interviewing 15 people an hour each, we were having these really long conversations, and everyone's like saying, oh yes, but of course there's this challenge and there's that challenge. And we did a whole card sorting thing, and we had like challenges galore. And what sort of struck us as we were looking at all of this is that many of these challenges could be divided into what you might call human challenges and technological challenges. So let's just explore the human side of the tree first. And the biggest, most obvious thing is the question of context. Whereas a human has some understanding of the question that's being asked, some understanding of the data that's going into, that's being looked at, computer just has no sense of what, there's no context, it's purely numbers. And the labels have no meaning to either, and especially in a tool like ours, which we deliver in 25 different languages. Even if we did put in a little bit of intelligence, that, hey, if you ever find the word total, treat it like this. Well, what's the likelihood of most of our clients using those words? So there's no latent understanding of the training data, the input data, the user's intent, what their goal is, and even if there was, there's no understanding of the recommendations that are going to be made. So if here's a model that just outputs an answer, does it know that you're trying to use the answer just to predict whether or not you're going to take an umbrella with you that day, a very low stakes situation, or if you need to know how much water is expected so that you can make some life and death decisions. And then I really liked this quote that somebody said to us. They said, even if you captured hundreds of dimensions of data, you can never capture the nuance of any complex phenomenon or experience. And you can sort of imagine, like, if you've ever filled out a user survey, you have some experience at a hotel or a restaurant, and they come to you and they're like, please tell us how we did. And even if they put 20 questions, 20 different questions, 30 questions, no matter how many questions they come at you and how much data that they can record about your experience, it doesn't capture the whole thing. It's just some data. And it doesn't capture the context of the experience. Another sort of set of challenges that people sort of raised with us was, we grouped them under the idea of design challenges. And the first design challenge is expectation. What's the user's expectation of what the model is supposed to do? And from a the UX designer's perspective, is how do you manage the user's expectation? The user sits down in front of we have a conversational assistant built into our tool. And because it's a conversational assistant, what you expect is that you should be able to ask a question. It's like, what product is giving me the greatest, what product is the most profitable product for my store this month? The user might expect an answer that would be actionable, But the AI would actually, you know, to be honest, hasn't been trained for that. At this stage, it's been trained to connect to the correct data set and maybe even do one query. But it was never really trained to do that. And how do you sort of design with, where do you put the guardrails? How do you indicate to a user what they should expect from this tool that you built? So we're in early days on that. There's these cultural challenges just within any organization, but as I was saying, between design and offering management and development, and this really the question of like who owns the project, who's driving the train. In actuality, developers build the stuff. We can't release anything without the developers really like nailing it. But offering management they're the ones that are talking to customers and they're telling us what the customers want. And then here we are as the UX designers, we also talk to customers, but we're sort of thinking about the experience of the product and what the tasks are. So we all have a different perspective of how a project should be managed and run and what it should do. And it's conflict. Offering managers, there's this great quote that Henry Ford said, if we asked customers what they wanted, they would have asked for faster horses. So is it fair to let the offering managers drive the train? Maybe not. Of course, we're biased, we're designers, so we think we should be driving the train. How many of you guys have heard this phrase, human in the loop? 2, 3, 4. Literally everybody we spoke with used that phrase, human in the loop. I was going to get t-shirts printed up that said human in the loop. It's maybe the jargonistic phrase of the year that refers to what's the user's role in any given AI project, really. It's like, can we build machines where the machine looks at the data, analyzes it, produces a recommendation and acts on that recommendation? No, that's ludicrous, of course. But at what point should the human be added to that process? Like, should the computer come and ask the human for input at every stage along the process? Well, no, perhaps that would be unnecessary too. So there's this balance, and people are really still working on this challenge. Like, it's not, there are no guidelines, really. There's no best practice that says users should be consulted at these stages. And then, and one of the things that we heard from participants is that the engineers we spoke with said, well, a perfect model doesn't require additional user input. And there's truth in that. A perfect model is perfect. But then we heard from a bunch of other people saying, well, no model is perfect. I mean, perfect is this sort of ideal end state that nobody has ever achieved. So it's foolish to assume. Another human challenge in implementing AI features is the explainability. That's the other term that everybody's referring to this year, is model explainability. Have you guys ever heard model explainability? Is that a term you guys have heard? Yeah. So there's 3 different levels of model explainability that I think are really important to distinguish. So the lowest level is in like in programming language, lowest level. The lowest level is for the AI researchers who are designing and optimizing machine learning algorithms. So they have to be able to understand what the model is doing, what's the difference between like a convolutional and a GAN and a this and that. Like, they really have to be deep in the weeds and understand how these models are working. They have to be able to visualize it and understand it and explain it. The next level of explainability, the middle level, would be the data scientists who are using models. So many data scientists and analysts don't actually know how models work, who could never really explain the math behind a model. But they're also in the weeds. They need to be able to train the model and, you know, measure its performance and explain like why the model predicted this versus that, what were the features that went into the prediction. And then the highest level would be the end users. And when I say end user, I mean like the customer who interfaces directly with the model, and that could be you at home looking at the recommendation engine on your Netflix, you're an end user. But another end user might be a bank loan officer who needs to explain to a customer, yeah, you've been rejected for this loan. And they have, you know, the customer says, well, why? And this bank loan officer has to be able to explain why did the model give you a bad score? So that's 3 different levels of explainability. And none of these levels are solved yet. There's a lot of work going on in that area, but it's still open. Trust, Anne mentioned trust. People need to trust models before they're going to use the model. And explainability is a big part of trust, but there's other factors like confidence and accuracy and reliability. And one thing that somebody pointed out is there's this concept called a trust spectrum. And the idea is that your requirements for trust change depending on the context that you're going to be using the model. So if it's a low stakes environment, then you may trust it. If it's a very high stakes environment, you're inclined not to trust it. And still the same model output, like using the same information, but whether or not you're going to use the model is sort of depends on. The next sort of branch of challenges, the technological challenges, and the big one for everybody right now is just that we don't have enough data. And that's sort of like hard to imagine considering this is like the age of big data, and like we keep hearing there's like more data generated like every day than in the past 100 years. I don't know what the numbers are, but like a decade's worth of data from the olden days is now produced in a minute. So to say, oh, there's not enough data, what does that mean? Well, really, that data has to be structured. It has to be, one of the things that's really sort of a challenge for our business users is they don't actually have it in a format that they can use it. Like, so companies, even a company like IBM, which is almost 100 years old, if that, like, how can I say it? Even if we have like warehouses full of documents, it's not accessible. That data is not like, as one person that we interviewed said, 5,000 Word docs are not very usable as training cases. Even if you can like electronically pull the words out of the Word doc, it's like, well, how do you, what are labels and what are values? And how do you extract the values and tabulate them so that you could feed them into a network? The next challenge is that so much of the data that even if we do have the data, well, how do we ensure that it's not biased data? So you may have the best intentions, but still but you just not realize that your data is biased. And I'm sure we can all like sort of brainstorm like 100 different reasons for why data might be biased. But you know, when it comes down to actually training a model, how do you distinguish good data from bad data? Like, just being aware that there's a chance that your data is biased doesn't necessarily give you the workaround to actually solve that your data is biased. A lot of people come up with, like we do it ourselves, we come up with all these like neat ideas for AI. It's like, hey, why don't we make an AI that can automatically design a great dashboard? You know, it's just like, and we're like, okay, that's really cool, but how are you going to train this? Where are you going to get examples of great dashboards so that you could train this model to design your great dashboard? It's like, oh, so then you kick around the idea of, well, why don't we crowdsource it? Why don't we like put it out to the world and let people like send us stuff, and you know, or there's like Amazon Turk where you can actually put a bunch of stuff up and you pay people to tag things for you. But how do you guarantee that they're doing it accurately? Even worse, how do you guarantee that there's no malicious players, trolls, who just sort of like who are giving you bad data? So there's this wonderful story about Microsoft who built a chatbot called TorCHI, and the whole story of that is that it was going to learn from its interactions with people how to have great conversations. But people are awful. And the chatbot had without context, and really there's really no way that you can sort of safeguard against people with malicious intent. So this chatbot just started repeating things that people had said to it, and they had to take it offline like within a week.
I don't think it lasted a day.
Less than a day.
It lasted a very short period of time.
Yeah. And then the next sort of technological challenge for implementing these features is the whole question of training. So you take all this data, you feed it into the model, and you're like, okay, I'm going to train it. But as somebody said, training isn't a once and done activity. Training has to be ongoing, and that's because the world is constantly changing. So there's this concept called model drift, where you might train the model based on the data that you have today, but as the world changes, as the population changes, the model is just spitting out recommendations or values based on what it has been trained on. So really, the workaround to that is we'll keep feeding it more data and use this concept called continuous training. But then that sort of, if your goal is it's like, okay, well, I'm going to solve this problem of model drift by doing continuous training, it's then you have this problem of learning, and the idea is that, well, models that learn from experience have to begin somewhere, and they're learning, where do they begin? So if you're going to learn from experience, well, you basically have to begin with no experience. So, but that's going to create a lousy user experience for anybody who's actually using this model. What do they base their recommendations on? So, just moving on to the takeaways. The main takeaway, once again, things are complicated. AI has come a long way in the past 10 years and continues to grow at an exponential rate, but it seems to us that the real world challenges may prove to be the bottleneck for future progress. So, another takeaway is that, based on our split with the human and the technological challenges, it looks like the human challenges there's maybe more room for development. Whereas the technological challenges of not enough data and biased data, I think, are pretty fundamental. I don't know where we're going to be 10 years from now. I personally am hopeful that that we can solve the human challenges, because these are, in some ways, UX design challenges. The question of expectation, and explainability, and even just the cultural challenges of like, how do you organize teams to build these projects? That's something that I think we can make progress on. And then the final takeaway is that we're trying to build these tools, we're trying to add these tools to a product that's in flight. And it's sort of like building a plane while it's already in the air. We have these workflows that kind of make sense, and what we need to do is step back and re-envision them. And that's terrifying to customers, and yet they're also very excited about it. So that's where we are. So, just to wrap up the 3 sections, AI transforms data visualization. That was the end section. And Chris, why don't you guys just come up? Because I think we're moving into the